Hi guys, welcome to Science with Miss Donovan and Kirby. Okay, for today's experiment we're going to do the It's a Drag experiment. This is a smaller part of a larger project that we're going to eventually do about parachuting onto Mars. So before you start the experiment, I want you to watch a video from NASA all about this experiment and what we are going to eventually be doing and how this one relates. So pause this, go over and watch that video that's linked down below. Did you watch it? Great. Okay, so for this experiment, every object that falls due to gravity will ultimately fall at a constant speed. So if you drop something, it's going to fall the same speed all the way down. So in order to slow it down, we need to apply drag to oppose the acceleration. So something that's going to slow our object down. One thing that you can probably think of is parachute. Parachutes are used for people who skydive to slow them down so they don't fall into the earth. So as drag increases, the object will slow its rate of fall. In this activity, you guys are going to see how different shapes influence drag. So we're going to be using a piece of paper for that, and I want to jump right into the experiment, so let's go. For this activity, you will need something to measure either 6.5 feet or 2 meters, depending on what you're using to measure. Something to mark off 6.5 feet or 2 meters. A piece of paper. A data collection sheet. I attached one to the file so you can print it out, or you can write your own based on the one that is attached, and something to write with. You're also going to need something to take time with, and probably the help of another person. You'll need to fold your paper in 5 different ways. So I'm going to show you the 5 different ways that I have my paper folded. Folded in half, folded in quarters, folded in eighths, folded diagonally twice, and folded diagonally 3 times. You can do whatever way you want to fold. These are just the 5 ways that I picked. So I measured 2 meters up the wall, so I know where to drop my paper from each time. I'll get closer so you can see. I have it marked right here, so I know where to drop from. And here's a momentary close-up video of Kirby. Hi. Alright guys, for the testing portion, we are going to be dropping our piece of paper several times and recording the time. So I'm going to be standing on top of this chair and dropping it from our measured 2 meters. I'm going to have my boyfriend RJ Wave, be the timer and the recorder. So he's going to time each of the drops and then write down the times for me in that chart that we did earlier. So we are going to do our first drop. Alright guys. What we're going to do is I am going to drop this piece of paper. When I say go, RJ's going to hit the start button, and when he sees it hit the ground, he's going to press stop, and then we're going to record it on our data sheet. You ready? Go. How many seconds?
1.66.
1.66. So he is going to record that on our data sheet, and we are going to do it 3 times for each of our folded papers. We're going to go in a time-lapse mode, and we'll see you at the end of that. So what you're going to do is you are going to find the average of each of your 3 trials for your drop. So how you do that is you are going to add up these 3 numbers, and then you're going to divide it by 3 to get your average. So I'm going to do all of the numbers right now. Once you have all of your averages calculated, we're going to start making our bar graph. Okay. You can see that I have made my graph based on the one that is attached from the worksheet. I changed the numbers a little bit on the side so they fit my numbers from my drop. You can either pause the video right now and copy my graph, or you can print out the one that is attached and work on that one. So what I'm going to do is I'm going to fill out each bar graph with the time from each of my drops. So we'll go into time-lapse mode while I do that. So what we can see from the graph is that for me, the smaller the paper is folded up, the less time it takes to fall. So that means it has less drag. The larger the paper is, the more time it takes to fall to the ground, which means it has more resistance from the air and more drag. So this is important information that we're going to use future on when we are making our parachutes for our cargo holds. So how did you guys do on this experiment? How did the shape of the paper affect the drag, and how do you think you can use this information in building your parachute later on? I also wanted to talk to you real quick about communication. If you used another person to help you time and write down your times for the dropping of the paper part, how did you communicate with them? Did you use verbal or nonverbal cues? Verbal is what I'm doing right now, I'm talking to you, and nonverbal could be a look. When I was dropping the paper with RJ, I used verbal cues. I would say go, and I would ask him if he was ready, but I also used nonverbal cues. I would look at him before I dropped. How did you do this? Did you have to change so you could communicate better? Were there times when you were dropping your paper and the other person wasn't ready to start? Communication is really important, and how we communicate with other people can affect how our message is received and understood and how the other person responds. Thank you guys for doing this experiment. We're going to be back next week doing an experiment about landing and how we can keep cargo in a hold. And hopefully this will lead into our larger experiment. So I will see you guys next week. Bye! About communicating the drag, and how do you think you can use this in small part of a larger